Hi everyone and welcome back to this Python course. Okay, so in the last lecture we've seen this math.log, right? And this math.log, we had here an interesting return, which is a 2.302585 and continues the number. This means that we are dealing with a float number, a number that accepts fractional values and a number with decimal points. Now, one of the interesting things is that it's not the number that we have right here that decides if this is a float or not. It's the type of function or even the fact that we are giving a dot or not. For example, a logarithm of 1 will yield 0. But notice, this is not the normal 0 that we see. This is 0.0, means that Python is telling us that, hey, this number is a float. Why is it a float? Because the math.log function returns a float. So this function, when it is designed, basically gets an input, it does something inside the machine of the function, in this case applying a logarithm, and outputs a value, right? That value type doesn't change no matter what we put in the input, of course outside errors. But in this case, what's doing in the output is giving us 0.0 that is a float, and this function always yields floats when we give valid numbers. Okay, so another important concept is that we can apply types directly to returns of the function. For example, I can encapsulate type here and call type on the return of this function, and this will yield float. Now, something important, doing this is exactly the same as doing this. Why is that? Because the inner function is evaluated first. So Python evaluates math.log 1 that will yield 0.0, and then it evaluates type on 0.0. So the outcome of the first function is what's going to be evaluated on the type. To make this a bit more explicit, let's see how this happens. So basically this type will yield this, we'll have this state, and then we evaluate the type on 0, which in this case will return float. Now this is the path that Python does when evaluating this expression type math.log 1. Okay, so it goes from here, goes to type 00 because this is what's returned from here, and then we evaluate and it's a float. So floats are these decimal point numbers. They are super interesting. Let me see, 10.5, 10.4, float. Remember when we've done divisions? Let's see, if I evaluate 10 divided by 3, we have as a float. Of course, because we are dividing numbers, and the division of these numbers, 10 divided by 3, will yield a float. Let's see if this is the same if we do 10 divided by 5. It is, even though 2 should be an integer number, the returning elements of dividing two numbers are always float numbers. Advantage of floats versus integers. Of course, there's more precision in the number, and there are certain numbers that need floats. Imagine if you are dealing with money, for example, or bank account statements. You don't want to round them every time you are doing some transactions on that money or bank account. So, of course, you need floats. For other precision calculations, you also need floats, of course. Now, the downside is that these numbers take more space in your memory, and having too many floats may break up your local system. Of course, this is like to billions and billions and billions of these numbers. That's it for floats. Functions between floats and integers are shared. Mostly, we can do absolute, for example, on minus 350.5, and we'll get 350.5 as a return. And most functions are shared between integers and floats. That's completely normal because they are both numbers. And we'll work a lot with these two data types throughout the course. This is just a brief introduction to them. Now, let's go to another data type that's super common, which is strings. And this one will have a bit more details for us to check. So let's do it. I'll see you in the next lecture.